Alrighty, welcome to the first set of notes for shapes. We spent 2 days in class working on this. The warm-up here, we just discussed where we see shapes. We looked around the classroom. We discussed where we see them in their everyday lives. Things like a stop sign came up, or rectangles on on the road. Like the dividers in the road. There's stripes there shaped in like rectangles. There's a bunch of different like power line or sewage accesses that are circular. I mean, they're everywhere around us, right? Everything around us is made up of different shapes. So we had a good conversation there. Basically, today's lesson is based around being able to define and identify different types of shapes, and then calculating the perimeter and area for these defined shapes. And those shapes I'm talking about here are different types of quadrilaterals, such as rectangles, squares, and trapezoids. We included triangles in there as well. And then we talked about circles and how radii, diameter, circumferences, chords, and tangents all relate to circles. So there's a lot here. A lot of it is review from stuff that you may have seen at some point in the past. So we defined shape and perimeter and area here, and defined in our own words how perimeter and area were different. And we had students in class share, and a lot of students came up with area is what is inside, whereas perimeter is the outside. Right? That was kind of a something that a lot of students came up with based on our conversation. That was really kind of simplified down. We can expand on that, but that's what it's going to look like when you simplify it. So example 1 here, based on our new knowledge, use the image below to calculate the perimeter area. Now we define this as a rectangle because it has parallel sides. Sorry about that. It has parallel sides here. Okay, let me actually get a marker. It has parallel sides. The blue and the red are parallel. Okay. And it has another set of parallel sides right here, the green and the purple, which actually makes it a parallelogram. Now, more specifically, what makes it a rectangle is the fact that this blue and this green are perpendicular to each other, because the slope of the blue is m equals 0, and the slope of the green is undefined. Okay, and when we have undefined slope and 0 slope together, that makes a perpendicular or 90 degrees, and that's happening all around here. So we've defined this now as a rectangle. Now, if you go and do some research on how to calculate the area of a rectangle, it's going to be length times the width, okay? Or base times the height. It's real simple here. Whereas the perimeter is just going to be 2 times the length plus 2 times the width. Or if you prefer base and height, like I do, it's 2 times the base plus 2 times the height. And basically that accounts for all of these sides here. So if we call this right here B for base, okay, and there's 2 of those bases, and we call this H for height, and there's 2 of these heights. We defined this base here as a base of 9. Okay, it goes from -4 to 5, so that is 9, which means this base up here is also going to be 9. And this height here goes from 2 on the y-axis, or sorry, -2 on the y-axis up to 2, which means this height is going to be 4. Okay, height is going to be 4. Height is 4. So if we're going to calculate this thing here, and we use 2 times the base plus 2 times the height, what that's going to look like is this. It's going to be 2 times 9 plus 2 times 4. And that is going to equal 2 times 9 is 18. 18 plus 2 times 4 is 8. 18 plus 8 is going to be 24 units. Now, if we do this, the same thing with area. Okay, what that is going to look like is 9 times 4. Okay, and that is going to equal 36, not units, okay, but square units. Square units, okay? When we're talking about area, we're talking about square units here, okay? Now, just some functions review here. By the way, what are the equations of the lines above? The green line there, the green line is a vertical line. All vertical lines start with x, so that's going to be x equals -4. So as you can see, it's going through -4 there. The x value there will always be -4 regardless of the y value. So again, every vertical line will be x equals. You have that purple line over there as well. Let's follow that same logic. If it's x equals, that is going through 5, so that's going to be x equals 5. Okay, now the blue line and the red line, those are horizontal lines. Those have slopes of 0. So that would be y is equal to 0x, a slope of 0, plus the y-intercept of 2. Okay, but technically you don't want the 0x. You don't need it. So instead, we just put y equals 2. And then down here, same thing with the red line. Y is equal to 0x. The slope is 0 plus the y-intercept of negative 2. But again, you're not ever going to see the slope actually listed there as 0. It's just going to be y equals negative 2. Just some functions review there. Example 2 here, we define this as a triangle because it has 3 sides. Triangles have 3 sides. Now, same thing as above. If you notice, hopefully, all I did here was I split the rectangle in half. So by the same logic, slope of undefined, slope of 0, that makes that a perpendicular. That is 90 degrees. Therefore, it is a right triangle. This is still 9. This is 4. Okay, now if you want the perimeter is just the outside, right? You just add all 3 sides. So the perimeter is equal to A plus B plus C, where A, B, and C are the 3 sides of the triangle, C being opposite the 90 degrees. And that's important when we consider the Pythagorean theorem. Now, if this is 9 and this is 4, and we need this third side here, we determine that diagonal by doing the Pythagorean theorem. Pythagorean theorem, just some more review from the geometry unit, is 4 squared plus 9 squared is equal to C squared. Okay, so that's going to be 16 plus 81 is equal to C squared. 81 plus 16 is going to be 97 is equal to C squared. Take the square root of both sides, and the square root of 97 comes out to about 9.8 or 9.9, real close. Let's just call it 9.9. Okay, so if you add all 3 of these sides up, your perimeter here becomes A, which is 9, we defined as, plus B, which is 4, plus 9.9. You just add all 3 of the sides. And that's going to be 18, 22, 22.9 units. Okay? Now, area, if you look up the area formula of a triangle, it's going to be 1/2 the base times the height. Now, what's kind of cool about that is it's the same thing as a rectangle here. This rectangle is base times height. But we don't want the entire base times height. We just want 1/2 of that. And that's what we did. We just split it in half, right? We split it in half diagonally. So if we move on down here, you can see this has been cut in half. So the formula for a triangle is base times height, but we are going to divide that by 2. We're going to take 1/2 of it. So the area is actually equal to 1/2 base times height, okay? And we just explained how we determine that. It's half of a rectangle. So if we determine the area here, we're going to go 1/2 the base of 9 times the height of 4. Now, 9 times 4 we already know is 36, and 1/2 of 36 is 18. So again, here we have 18, not units, but square units. Area is always square. Now, the equation of this black line, not quite as easy as a horizontal or vertical line. In this case, we actually have to determine the slope. Okay, and the slope here is, we're going to do some rise over run action. We're going to rise, get my marker here. We are going to rise 4 units and run 9 units. So my slope here is 4/9. Now, all you need for a line to determine its equation is a point and a slope. And this point right here is at -4, -2. So let's go on down here. We have -4, -2. Okay, so the point we have is -4, -2. And the slope we defined as 4/9. And if we put that into point slope form, it's going to be y minus the y coordinate. So it's y minus a -2, which turns it into y plus 2, is equal to m, which is 4/9, times x minus x1. And our x1 here is -4, so it's x minus a -4, which turns that into plus 4. Okay, so that's going to be a possible equation for our black line. Okay, now example 3. This right here, a lot of students said, well, hey, I don't know what this shape is, but I can split it into a couple shapes I do know, a triangle and a rectangle. And that's great. You can find the area of the triangle, find the area of the rectangle. But this shape is actually what's called a trapezoid. Okay, and a trapezoid can be determined, the area can be determined by this fancy formula. You can look it up, but the area is base 1 plus base 2 multiplied by the height. Let me back up here. It's going to be important for order of operations. Base 1 plus base 2 multiplied by the height. And then you're going to take that whole thing, okay, and you are going to divide it by 2. Okay, this whole formula is divided by 2. So you add the bases, multiply them by the height, and divide by 2, and that gives you your area formula for a trapezoid. Now the two bases, let's add a little side note here. The two, and it's weird to think of two bases, but the two bases of a trapezoid are the two parallel sides. So if you look at the four sides of this trapezoid here, the two parallel sides are the red side and the blue side. All right. So if we determine those two measures there, let's see, this measure here is 3. Okay, that length is 3. And this length down here is 9. So those are going to be your two bases. And then this height is still 4. Okay, so these shapes are all very similar. The shapes of, if you look at the last two examples we did, those lengths have not changed much. So if we want to calculate the area here, we have our two bases of 3 and 9. So we're going to go area is equal to 3 plus 9, our two bases, multiplied by our height of 4, all divided by 2. So if we start simplifying this, that's going to be 12 times 4 divided by 2. That is going to be 48 divided by 2. And our area for the trapezoid ends up being 24 square units. 24 square units for our area. Now, to find the perimeter, there's no really fancy formula here. What you're going to have to do is you're going to have to just add all the sides up. So we have 9, we have 4, we have 3. We have 3 of the 4 sides that we need. Okay, but this orange side here, we're actually going to need to do Pythagorean theorem on again. So let me outline the triangle here in red so you can actually see it. So this triangle here is the one that we're going to want to do Pythagorean theorem on. So this base is 6. This height of this triangle is still 4. And then we're going to solve for this missing diagonal C. Now, if you do Pythagorean theorem here, we're going to do 4 squared plus 6 squared is equal to C squared. You're going to work your way through and solve for C the same way we did up above. That's going to be 52 is equal to C squared. You take the square root of both sides, and that is going to be a decimal. It's going to be something like 7.3-ish. Okay, about 7.3. So we can say C is equal to about 7.3. And to find the perimeter, you're just simply going to add this, the 3, the 4, and the 9. And that's going to give you your grand total for your perimeter for this trapezoid. Okay. Now, again, just some quick review here. For the orange line, I would put this in point slope again. The slope, if we do some rise over run again, the rise here is 4. Let me get the pen out. The rise here is 4, okay? And the run from here to here looks like it is 6. So your slope is 4 over 6, which reduces to 2/3. And then all you have to do is just identify a point. Let's use -4, -2 again. Okay, so we're going to use this slope with the point -4, -2. And you are going to put that into point slope form. So that's going to be y minus our y value of -2. So that again becomes addition is equal to our slope of 2/3 times x minus x1, where our x1 is again a negative, so it becomes addition. And that's going to be our equation for the orange line. All right. Down here on example 4, looking at something a little bit different. Your base and your height. So just a little side note here, going back to triangles. The base and the height of a triangle must always be 90 degrees, okay? Or in other words, perpendicular, okay? So if we identify, in this first one, if we identify this guy right here as our base, the one in red, okay, we're going to identify this as our base. And again, that's still 9 units. And we identify this right here. Let me erase this, clean this up a little bit. We identify this right here as our height, because if we drop this down, directly down, that creates a 90 degree. That height there is 4. So if we want to determine an area here, we're just going to simply do 1/2 the base of 9 times the height of 4. 9 times 4 being 36. 1/2 of 36 being 18 gives us an area of 18 square units. Okay. Now this one is a little trickier to see visually. But again, if we define this as our base here, and that base there goes from -4 to 0 on the x-axis, that's going to be a base of 4. Now the opposite altitude, that's what we call it, the opposite altitude of the triangle is right up here. Now this base, if you were to extend this thing either direction with a dotted line, if you were to drop directly down from this height, this would be your 90 degree angle. So your height actually occurs on the outside of the triangle. It's a little bit funky, but your height is going to be right out here. It's going to be 4. So our area is going to be 1/2 the base of 4 times the height of 4. 4 times 4 being 16, and 1/2 of 16 is 8 square units for our area. Okay. Let's see here. And we calculated these areas right up here. Okay. So let's jump down here. This is just kind of a side note, kind of something cool about triangles you can look into. It's known as an orthocenter. We just had a quick discussion on this. It's not something you're going to be tested on, but it's just something to kind of pique some interest. If you're interested in going further and reading into triangles a little bit and some of the cool things that exist within them, feel free to do a little research on the orthocenter. All right. Now, last thing we talked about was a circle. Very important about circles is what's known as the radius. Okay, the radius goes from the center to a point on the circle. So the radius here is 2. And that would be true. That's consistent with any radius within the circle. Every radius here is going to be 2. Okay, so the radius of this triangle is 2. Now, the diameter is always going to be directly across a circle. So that diameter is always double the radius. The diameter here would be 4. Okay. And there's just a couple formulas you're going to have to look up. Should, again, be a review here, but the circumference of a circle is 2 pi times the radius. Okay, 2 pi, let's put that in parentheses, 2 pi times the radius. So the circumference here is going to be 2 pi times the radius of 2. So our circumference here is going to be 4 pi. And it's going to be units, right? Because the circumference is around the outside. The circumference is just another word for perimeter. So if you look up in the definition of a circumference, the circumference is just the perimeter of a circle, okay? So the perimeter is what's in purple here around the outside. So that's just going to be 4 pi units, not square units, but units. Now our area formula is going to be pi times our radius squared. Okay, so that is going to look like this. It's going to be pi times our radius of 2 raised to the power of 2. And 2 squared is 4. So this ultimately becomes 4 pi. Now that's different from the 4 pi above because this is a distance of 4 pi. This is 4 pi units squared. Okay, because now we're talking about the inside of the circle. Okay, before the circumference, we're talking about the outside of the circle in purple. The area is talking about what's inside. So it's basically, it's a different measurement, right? Okay, so 4 pi square units and 4 pi units are different. Just real quick, some more definitions. We already defined a radius as, let me get a straight line tool here. We defined a radius as from the center to a point on the circle. So that's a radius, but this would also be a radius, right? Those are both radii. Now, a diameter is going to be from one point on the circle to another point on the circle, and it has to go through the center. So we have our diameter here in green. Another diameter would look something like this. That would be another diameter. So we have our radii in blue. We have our 2 diameters in green. We also have part C here, draw a line that intersects the circle twice but is not a diameter. So that would look something like this. Let me do it in purple. Okay, that would be something like that, right? So that connects 2 points on the circle, but it doesn't go through the center. This right here is what's known as a chord. So technically the diameter, the green lines are also chords, but that purple line is a chord that is not a diameter, okay? This last one here, draw a line that intersects the circle exactly once. So this one's kind of cool. This is something you're going to hear in higher levels of math. This is what's known as a tangent line. Okay, it's going to look something like this. And actually, let me do this in a different color. Let's do it in, we already used blue. Let's use red. The tangent line is going to look something like this. It just comes through and it touches, just barely touches. Let me see if I can clean this up a little bit. I'd like to move this second line I made so that it actually connects. I struggle with that a little bit. There we go. All right, this red line right here, that intersects the circle at one single spot, okay? And that didn't end up being red. I'm sorry. But that red line and that, there it is. There you go. Okay, that right there makes what's called a tangent line. Okay, it touches at a single spot. Okay, this right here is known as a tangent, okay? Lastly, a couple challenge problems here. Kind of cool to mess around with, but the circumference of a circle we need to determine, and all we're told is that the area is 36 pi. Okay, now the area is 36 pi. Okay, we know the area of a circle is also pi r squared, though. All right, it's also pi r squared. Now the circumference, in order to determine a circumference, the circumference is 2 pi r. The one thing that we need is the radius to determine the circumference. We don't have enough information to determine the circumference yet, but we can determine the radius. And the way we can do that is we can set 36 pi equal to pi r squared. Because we have pi on both sides, you can eliminate them, you can cancel them. So what that leaves us with is 36 is equal to r squared. And if you take the square root of both sides, that gives you r is equal to 6. Okay, r is equal to 6. Now from here, you can solve 2 pi times 6, and that gives you a circumference of 12 pi units. You just had to first solve for that radius, and once you had the radius, you could then plug it back in your circumference formula. Now B, we're going the other direction. Determine the area of a circle with a circumference of 12 pi. Now the circumference is 12 pi, but we also know that circumference is 2 pi r. What we want is the area, and the area is pi r squared. Now once again, the important point here that we need that we don't have is the radius. So we're going to use what we do know to determine the radius. We know the circumference is 12 pi, and we know the circumference is also equal to 2 pi r. So we can set 12 pi equal to 2 pi r. And same thing we did over there, similar. We can get rid of the pi's that exist on both sides. And what we're left with here is 12 is equal to 2r. Divide each side by 2, and you get r equals 6. Now you can take that 6 and plug it back in for r right up here. Okay, so we're going to go pi times 6 squared. 6 squared is 36, so our area is going to be 36 pi. Okay, 36 pi square units is our area. All right, so long day of notes. That took us 2 days to get through. And in this video, it took us probably about 20 minutes to get through. Break it down. If you need any extra help, talk to your teacher, email your teacher, whatever it may be. Go through this slowly, test yourself. Thanks for watching. Good job.